Now we're going to look at 15A and B. For the first one, if you'll notice, it says that you have 2,500 grams of ice melted at its freezing point. So if you're at the freezing point and you're melting a solid or you're freezing a solid, you're going to use a different equation because we're just doing a phase change here. We're not doing a temperature change. So in this particular case, the equation that we'll use is going to be Q is equal to the mass of your substance times the heat of fusion. And in the PowerPoint, you should have seen that the heat of fusion for water is approximately 335 joules per gram. This is the amount of heat energy it's going to take to melt or freeze a substance, freeze water, to freeze 1 mole of water at its freezing point. So basically what we're going to do is, going back to our problem, we had 2,500 grams of ice. So that's going to be our mass. And since we're changing phases between liquid and solid, then you're going to use the heat of fusion. So that's the value that we are going to use here. And the rest now is just plugging in. So we're solving for Q. Again, it's the amount of heat needed for this process. When you do a phase change, it's going to require a good bit more heat than some of the changes we've seen before where you're just changing within the same phase. So you'll see our gram units are going to cancel here, and we simply multiply the 2,500 by the 335, and our Q value will be 837,500 joules. Now determining whether these are exothermic or endothermic is a little harder because you have to think about what's happening in the system. So we, the people, or whoever's doing this, is they are in the surroundings. And so whatever we interpret is actually happening opposite in the system where the change is taking place. So if you're actually melting ice, the ice has to absorb heat so that it can melt, and therefore this would be actually an endothermic process. Now let's look at 15B. This one's a little different as well because this time you're actually looking for the mass this time. So we're looking for the M value, and we have steam. It says, what is the mass of steam that is formed when water absorbs 755 joules of heat? So that's our Q value at its boiling point. So if it's at the boiling point, then basically you're going to be taking liquid water and boiling it into steam, or you're doing a phase change at 100 degrees Celsius. So we're not doing a temperature change, we're just doing a phase change. So again, our formulas are going to be a little different this time. It'll be our Q is going to be equal to our mass, and then times our heat of vaporization. And for water, this value for heat of vaporization is 2,260 joules per gram. And again, it's kind of rounded from what you might look up in a textbook. It just makes it easier to learn. So we have our Q value here as 755. We're looking for the M value, and then our heat of vaporization is 2,260 joules per gram. Our joule units are going to cancel, and of course then our grams will go back on top, and we'll have a mass unit of grams. So I would divide both sides then by 2,260. And our final answer should be 0.334 grams of steam. Now if you're boiling something, then you're taking a liquid to a gas, which means the liquid has to absorb heat. So if you're absorbing heat, that is also an endothermic process. Now if we go the opposite direction and we take a gas and we convert it into a liquid, or we undergo condensation, then the gas actually has to lose heat in order to condense, and therefore this would actually be an exothermic process. And then if we look back at our solid versus our liquid, if we go from a liquid to a solid, or we freeze something at its freezing point, then again the liquid has to lose heat in order to freeze, and that is also exothermic.